So welcome everybody to this latest A2 video 162 maths, and in this video we'll be continuing with series and sequences. However, this time we'll be looking at geometric progression, also known as GPs, and looking at finding and using the nth term. So in a geometric progression, each term is obtained by multiplying the previous term by a constant r. This number r is called the common ratio. So for example, if we start off by our first term, which again we'll call a, then what we're then going to do is we're going to multiply this a by our common ratio. So we're going to multiply that by r, thus giving us a r. Now if I then multiply that by r, then I'm going to get my next term, which is going to be ar squared, and then I multiply that by r, and that's going to give me ar cubed. Now what you should notice is, if I just label this, so this is my first term, this is my second term, this is my third term, and this is my fourth term, that the value of r and the term in which it is always one less. So therefore, what we then end up with is that if I want to create the nth term, it's going to be to the power of 1 minus n. And here, this is where we get our nth term formula. So let me just write nth term there. So in terms of formulas for a geometric progression, our nth term formula can be represented like so. So it's going to be un, which is the value of the term. So value of the nth term. And this is the formula that represents the nth term. So the nth term formula. Now what is important, where a is obviously, where a is the first term, r is a common ratio, n is the term number, and un is the number in the sequence at place n. Now when a and r are numbers, you need to make sure that you are writing it numerically as a times r to the power of n minus 1. And the reason for that is, if I took the example of, let's say, if a equals 3 and r equals 2, then what you don't want to be writing is 32 and then n minus 1, because that's not going to work. So even though the nth term is written like this, this is how we actually need to represent it. And this is definitely something that's worth putting in your notes, but if you are given a formula book in your exam syllabus, then it tends to be given to you. So let's put into practice on some commonly asked questions. So in this particular question, we're asked to find the nth term of. Now, in terms of this, we're not being given any indication of whether it's an AP or a GP. So what we need to do is use our common sense to just decipher which of the two it actually is. Now here, I know it's not going to be an AP simply because the difference between each of the numbers in the consecutive terms are not the same. So it's more likely going to be a GP. So for this, what I would always recommend that you do, so the very first thing you want to do is label each term algebraically. So here, 2 is going to be A, 10 is going to be AR, 50 is going to be AR squared, and 250 is going to be AR cubed. So from this, I can see straight away that A is going to equal 2. So then from this, I can then say A equals 2. Now to find R, all you need to do here is simply divide two terms and label algebraically. So what I mean by that is, if I take any two terms, so let's take 10 over 5, and that's going to be equal to AR over A. And as you can see from this, is that the A's are going to cancel, which then leaves me with R. So therefore R is going to equal 10 over 5, which is equal to 2. So in terms of the nth term of this particular formula, what's that going to be? Well, it's going to be, well, a times r to the power of n minus 1. So if a equals 2 and r equals 2, it's going to be 2 times 2 to the power of n minus 1. And again, try and not think a bit too smart and trying to simplify 2 times 2 to equal 4, because it's not going to work that way, and it's certainly not going to give you this particular nth term in terms of numbers in the sequence. Now in terms of b, so again I can see straight away that a is going to equal 5. So here I've got a equals 5. Now again, what to find r, just take any two terms. So just to prove a point, what I'm going to do is I'm going to take this term, which is ar, and I'm going to take this term here, which is ar, and that's going to be cubed. So if I take these two terms here, so if I do ar cubed over ar, and I always take the latter term first just to make it so I'm not dealing with negative powers. So here I'm then going to substitute the numbers. I've got minus 135 over minus 15. And then from this I can cancel my fractions. So I've got cancel the a's. I can also cancel an r, so it becomes r squared. So then what that then shows is that r squared equals minus 135 over minus 15, in which then I can just simply reach for my calculator and try and work that out. Now just be mindful that when you are working with negatives that you are, so try not to trust too much in your calculator, because obviously you need to make sure that you are using your calculator correctly. So 2 minuses make a positive, so I've got r equals, and it's going to be r squared equals 9, so r equals plus or minus 3. Now the problem with this is I've got two potential values of r. So r could either be positive 3 or r could equal minus 3. Now the only time it'll equal positive 3 is if obviously you're trebling the numbers. That's if all the numbers are going to be positive. So if the terms are oscillating, so if terms are sort of oscillating with regards to signs, and that mean by positive or negative, then r is going to equal a negative number. So here my r value is going to be minus 3. So right in the nth term of this sequence is going to be 5 times minus 3 to the power of n minus 1. And there is my nth term for this particular sequence. So looking at our second example, it says find the 25th term of the geometric series. Now the fact that it's a series is just basically because we've got pluses in between each of our terms, but we still work this out in the very similar way. So the first thing I need to do here is find the nth term, and so from this we want to find a, which is going to be equal 5, and then to find r, all I've got to do is just divide any two consecutive or any just two terms together. So again, it doesn't really matter which one you're going to go for. I'm going to go for, well, if I label that as the first term is a, 10 is going to be ar. So here we've got ar over a, which is 10 over 5, which again r equals 2. Now obviously if you can familiar with these and you can spot what r is, obviously we can see that the numbers are doubling, so that r is going to equal 2. So what we then end up with is we've got 5 times 2 to the n minus 1. Now to find the 25th term, that is when n equals 25. So all I've got to do is substitute 25 as n, so I've got 5 times 2 to 25 to minus 1, and again I type that into my calculator. I've got 5 times 2 to the power of 24, and it gives me an answer of 83886080. There is my final answer. So looking at our third example, so the question says that the fifth term of a GP is 567 and the sixth term is 1701, and the question is asking me to find the nth term of the sequence. So in terms of the information that I've been given, well, I know that the fifth term is 567 and I know that the sixth term is 1701. So now the fifth term, which written in terms of nth term is going to be a times r to the power of 4, and that equals 567. And obviously another way of writing this would be ar4. And the sixth term is, which is ar5, is going to be equal to 1701. So here if I do the sixth term divided by the fifth term, and algebraically that's going to be ar5 over ar4, and that equals 1701 over 567. Then simplifying the algebraic fraction, the a's cancel, and the r's I can reduce down. So 1701 divided by 567 is going to equal to r. So therefore r is going to equal, and again reaching for my calculator, not my calendar, we get an answer of 3. Now from this, what we can then do is, well, if ar to the power of 4 equals 5, 6, 7, and r equals 3, then I've got a times 3 to the power of 4 equals, I don't know what number that is, so let's just try that again. So 5, 6, 7. So I can divide by 81. So 5, 6, 7 divided by 81 gives me an a value of, and just typing that in, 7. So therefore the nth term is going to equal 7 times 3 to the n minus 1. And there is my nth term formula. And now let's have a look at our fourth example. So here it says that the 7th term of a GP is 70, the 9th term is 280. If r is greater than 0, find the nth term and the 5th term. So there's quite a few parts of this particular question. So in terms of labelling the key information, I know that the 7th term equals 70. I know that the 9th term is 280. So from this, I've got that ar to the power of 6 equals 70 and ar to the 8 equals 280. So very, very similar to what I did in question 3. Let's divide the terms up. So I've got ar to the power of 8 over ar to the power of 6, not 2 because I'm kind of forward thinking, I've already done it in my head. 6, and that equals 280 over 70, and that's going to equal r squared, so that's going to equal 4. And so from this, what I've got is that r equals plus or minus 2. Now the fact that it says that r is greater than 0 means that so as r is greater than 0, r has got to be equal to 2. So again, now that I've got r, all I've got to do then is using that ar to the power of 6 equals 70, and that r equals 2. I've got a times 2 to the power of 6 equals 70. So a equals 70 over 2 to the power of 6. So 70 divided by 2 to the power of 6 gives me 35 over 32. Now sometimes this can happen, so I'm going to leave it as a fraction. So my nth term is going to equal 35 over 32 times 2 to the power of n minus 1. Now in terms of that's the first part, the next part then asks me to work out what the 5th term is. So the 5th term is going to be 35 over 32 times 2 to the power of 4. And again, if I just simply type that into my calculator, so 35 over 32 times 2 to the power of 4, and that gives me 35 over 2, or 17.5. And there we go.